Uranus looks calm. From far away, it is almost disappointingly simple. No giant red storm, no bright rings grabbing your attention, just a smooth blue-green world drifting in the dark. And that calm picture is the first thing that goes wrong. Because Uranus may be one of the most damaged planets in the solar system, it does not spin the way a normal planet feels like it should. It rolls. Its axis is tilted by about 98 degrees, which means Uranus is basically rotating on its side. If Earth did that, our idea of seasons would completely fall apart. On Uranus, they do. Near one pole, the sun can stay up for around 42 Earth years. Then, it can disappear for another 42. One long day, one long night. Not weather the way we know it. More like a planet living through geological scale mood swings. So right away, Uranus stops being the forgettable one. It becomes the knocked over world. And once you see that, the next question is obvious. What could possibly do that to an entire planet? The leading idea is not subtle. Early in the solar system's history, Uranus may have been hit by a massive protoplanet, likely a body a few times Earth's mass, in a giant glancing collision. Not a head-on destruction, more like a cosmic sideswipe, enough to shove a world off balance without tearing it apart completely. Current models suggest that one event could help explain why Uranus ended up rolling around the sun instead of spinning upright like most other planets. And if that impact really happened, it may explain something even stranger. Because Uranus is not just tilted wrong. For a long time, it also looked thermally wrong. Giant planets are supposed to leak leftover heat from their formation. Jupiter does it. Saturn does it. Neptune does it. Uranus, for decades, seemed weirdly quiet by comparison, as if its internal heat had almost vanished. That helped build its reputation as the cold, sleepy outer planet. But newer work has changed that picture. Uranus does appear to emit more energy than it receives from the sun after all. Not a huge amount, but enough to matter. Enough to say this planet is not simply dead inside. That changes the feeling of the whole planet. Because now the mystery is not, why is Uranus empty? It is, why is Uranus holding so much back? One idea is that the ancient impact did more than knock Uranus over. It may have rearranged the interior. Some simulations suggest the collision could have created a hot, disordered inner layer that traps heat, almost like putting a thick lid on a furnace. So Uranus may not be cold because it has nothing left to give. It may be cold looking because the heat is having a hard time escaping. Not heatless, heat locked. And that is where Uranus becomes more than a weird planet fact. It starts feeling like a wound, a very old one, a very large one, a planetary injury that never fully healed. But the deeper you go, the stranger it gets. Because if Uranus really has a bizarre interior, then you would expect its magnetic field to be bizarre too. And it is. Voyager 2 discovered that Uranus's magnetic field is wildly offset and tilted compared with its rotation. On Earth, the magnetic field feels relatively centered and familiar. On Uranus, it is as if the planet's invisible protective bubble has been built crooked. The magnetic field is tilted by about 59 degrees from the spin axis and offset from the planet's center by roughly a third of the planet's radius. That is not a small quirk. That is a fundamentally weird system, which raises an uncomfortable possibility. Maybe Uranus is not just strange. Maybe our one close-up look at Uranus was strange too. Voyager 2 is still the only spacecraft ever to visit the planet, and it flew past in January 1986. Just one pass, just one encounter. And for decades, that brief visit shaped the global mental image of Uranus. Cold, bland, simple, almost inert. But a 2024 reanalysis of the old Voyager data suggests something remarkable. When Voyager arrived, Uranus's magnetosphere may have been compressed by unusual solar wind conditions, potentially putting the spacecraft through a magnetic environment that was not typical at all. The study estimated that Voyager may have seen Uranus in a state that happens less than 5% of the time. That is a crazy thought. We may have judged an entire planet from a very strange day. So now the old picture starts collapsing even faster. The smooth blue sphere was never the full story. Modern observations from Hubble, Keck, and Webb have been steadily peeling that story apart. Uranus has shown major storms. It has shown changing haze and cloud structures. Hubble's long-term observations found that as Uranus moved through its extreme seasons, the North Polar region brightened dramatically, with aerosols thickening as the planet approached northern summer. In plain English, sunlight seems to be reshaping the atmosphere over decades, in a way we can actually watch happening. Uranus is not static. It is evolving in slow motion, and that matters because the popular image of Uranus has always been visual first. It looked blank, so we treated it as blank. But blank is not the same thing as simple. That mistake gets even bigger once you ask the most basic question of all. What is Uranus actually made of? For years, the clean answer was that Uranus and Neptune are ice giants. But that label sounds more settled than the science really is. In planetary science, ice does not mean frozen chunks like a glacier floating through space. It usually means materials such as water, ammonia, and methane in deep planetary interiors, often under enormous pressures and temperatures that are nothing like ordinary ice on Earth. Even that simplified picture may not be enough. A 2025 modeling study found that the current data still allow a surprisingly wide range of possible internal compositions for Uranus and Neptune, including models that are much more rock-rich than the textbook version people usually imagine. That does not prove Uranus is definitely a rock giant. It does something more interesting. It proves we still do not know this planet as well as the label suggests, and that is the real shift. The deeper story is not that scientists found one clean replacement answer. The deeper story is that Uranus may be one of those worlds where the category survived longer than the certainty. We gave it a neat box before we finished the mystery. If you step back, that makes Uranus feel less like a boring edge-of-the-map planet, and more like a preserved record from the violent early solar system. Its tilt may remember the impact. Its trapped heat may remember the impact. Its magnetic weirdness may remember an interior that was rearranged by the impact. Even its reputation may remember a misleading first impression from a single flyby in 1986. And there is something eerie about that. The planet looks so smooth, so finished, so quiet, but current evidence suggests Uranus may be carrying the consequences of ancient chaos in almost every major way we can measure. If Earth were placed next to Uranus, the size difference would already feel huge. Uranus is about 4 times Earth's diameter and more than 14 times Earth's mass. Yet the gravity at the cloud tops is only a little weaker than what you feel standing here on Earth. That makes Uranus feel, in a very human way, even stranger. A much bigger world that would not instantly crush you with surface gravity if there were a solid place to stand, which there is not in any ordinary sense. It is a giant planet that looks approachable from one angle and completely alien from every other. And if you were somehow floating near one of its poles during one of those decades-long seasons, the sky itself would feel wrong in a way no human culture has ever evolved around. Not days and nights, not winters and summers, entire eras of light, entire eras of darkness. Uranus does not just have weather. It has atmosphere on a timescale that feels almost planetary even to us, which is why the next step matters so much. We really need to go back. NASA's most recent planetary science decadal survey prioritized a Uranus orbiter and probe concept as the top large new flagship priority for the coming era of solar system exploration. The reason is simple. For a planet this important, our direct measurements are absurdly thin. A new mission could track the magnetic field over time, probe the atmosphere, map gravity in detail, study the rings and moons more closely, and finally test which of these competing interior models survives contact with better data. The most favorable launch opportunities identified for that mission architecture are in the early 2030s, using Jupiter for gravity assist, and that future mission would not just be about Uranus, it would be about fixing a blind spot in how we understand giant planets in general. Because if Uranus can look this simple while hiding this much uncertainty, then simple may be one of the most dangerous words in planetary science. A planet can look like a smooth blue ball and still be the aftermath of a colossal collision. A planet can look cold and still be holding heat inside. A planet can sit in a textbook for decades while its actual interior remains unresolved. A planet can become a joke in popular culture while quietly being one of the best preserved clues to how the solar system became what it is. That, to me, is the real payoff of Uranus. Not that it is weird. A lot of things in space are weird. It is that Uranus is weird in a connected way. The tilt, the seasons, the heat problem, the magnetic field, the uncertainty about the interior, the need to go back, all of it points to the same unsettling possibility. We may have spent decades looking at a planet-sized scar and calling it a planet. And if that is true, then Uranus is not the forgettable one. It is the one that was quietly warning us about something bigger, that planets are not always clean categories, that calm surfaces can hide violent histories, and that the solar system we think we know may still contain worlds whose real stories only begin once the simple picture breaks.